Welcome to section 9.3. As described on the page, and then also in probably an overview video or in the section as you read it through in the book, this is a section in which we have dependent data that has to then be paired up so that we can look at it. Because of that, we can't give you the summary statistics, because what we can give you is the individual data that's there, but in order to compare them, we're going to do that through subtractions. So everything's done through subtractions. If I take and subtract two things, I know a lot about them. If their subtraction is equal to 0, then I know they're the same. If their subtraction is equal to a positive number, then I know the first one's bigger. If their subtraction is equal to a negative one, I know the second one's bigger. And we've kind of got a look at that even in the earlier sections as we've looked at the confidence intervals associated with subtractions. And so I wanted to give you a video on how to do the 9.3 homework using StatCrunch and grabbing your actual homework. So as you sit down to do the homework, this is what you'll see. I think the first question is actually the hardest, and then the remaining 7 are all very, very similar to one another. And so it says, listed below are the body temperatures from 5 different subjects measured at 8 a.m. and again at 12 a.m. Find the values of the D bar and S sub D. So D bar and S sub D, D bar is the average difference, and S sub D is the standard deviation of the differences. Both of those are needed in the test statistic formula that you actually never have to see if you're using StatCrunch. The test statistic just pulls out for you. So let me show you how this is to be done. So when you go to do this, you're going to go to Stat, and what you have is T-statistics when you have paired data. Now, how do I know it's a t-statistic? Because we're looking at the average difference, right? You see D bar here for the average difference in the sample, and this is the average difference for every temperature ever taken at 8 a.m. and noon. Averages have always been a t, and so this is a t-statistic, and we're dealing with paired data. When you click on that, it's going to want to know what the data is. And so, unfortunately, I haven't listed any data. So let me click off of this, and we need to put the data right here. The data needs to be matched up exactly. So I'm going to put the first temperature at 8 a.m. in this first column. So even though this data is distributed in rows, the way that the StatCrunch will grab it is it will be looking for columns. So var 1 is going to be the temperature at 8 a.m. And so I'm just going to type in 98.5. That's the first one I see. Go down. Hit 99.4. Go down. You get off of that so you can see that better. And then after 99.4, there was a 97.9. And we're literally just typing in the data. 97.4. 97.1. So in the other column, I'm going to put its paired data, which was the temperature at noon on the same day, 99.1, 99.6, 98.4, 97.1, and 97.4. So there's my paired data. And if you ever find that when you plug in an answer and it doesn't work, you may want to look to make sure you typed all those in correctly. Just give it a quick double check. That can easily happen where you mistype something in. But you need to type that data in. And now when I go to Stat, I'll hover over it. I think that's what I need to do. And go down to T-statistics and go to paired. The data in column 1 is going to be that first sample, right? And the data in column 2 is going to be the second. Now, don't worry about this, like the where and the group by. And you can leave it on hypothesis test. We're not actually doing a hypothesis test. But when you hit compute, it's going to give you some things that you need. You need this mean. This is the mean that it's talking about. 0.26. That's what D bar is. So what D bar, how that was calculated is they took the differences of all those. They took 98.5 and subtracted 99.1, made note of that number, and they gave you the mean. And so you can plug that in. So that mean is the mean of the 5 pairs of data that you plugged in when they were subtracted, negative 0.26. And when you hit enter, it's going to say good job. Now I messed up before. I thought that standard error, I know what standard error is, and unfortunately it's not standard deviation, but I interpret it that way. So I put in 0.16, right? And it's going to tell me, oh, that's wrong. It's not geared to tell us what the standard deviation is, so I need to tell you what to do. I'm going to go back to options and show you what I did to circumvent this. I clicked on this box that said save differences. Now this is the only problem I saw that you had to do this in. And I'm going to hit compute. And what it's going to do is actually pretty helpful for me to describe what just happened. When they came up with this 0.26 that I have highlighted here, the negative 0.26, it was the average of that difference column right here. It's the average of all those differences. So we can see that the differences are always negative except for this one right here, right? That one was a little anomaly, but the average was negative. It never told us our standard deviation. So what I would recommend then is going to data and, I'm sorry, not data, go calculators. I forgot actually how I did that. Okay, compute from column. I think that's how I did it. So select a column. We want to get the differences, and we're going to hit compute. Oops, that didn't do it. So what do we need to do here? I actually did it before. Oh, maybe under, that's where I was, sorry. Summary statistics, I'm sorry. That's what we wanted. So sorry to waste your time there. We want the summary statistics from a column. And then we're going to choose the column. We're going to choose the differences column. And what we want out of that, we want the standard deviation. So look what happens when I hit compute. It's going to give me some of the same information that I had before. The 0.26, the standard error that I mistakenly thought was standard deviation, right? Here's the standard deviation, 0.35. So that's why it wasn't right. And that other one is not geared to give that to me. It just gives me the sample mean as well as the information needed to test a hypothesis. And so you're actually not going to need to know that sample standard deviation for the differences outside of this one problem, but it would have been a little bit hard for you to see that. So if I remind you what we did, the first thing that we did is we recognized that we needed to get some other things. And so when we redid this, actually I can bring it back up. I don't know if it will. Oh yeah, the 3 hidden results. Yeah, so if we looked at this one right here, this is the first thing, and we recognize, oh, it didn't have the standard deviation. Then we said, okay, let's compute the column. So we're going to compute some data, and that one wasn't very helpful, right? So I made it give me the differences in there. And then I realized, oh, the right button to hit was summary statistics. I just was overlooking it from a column. And we chose that differences column and hit compute. And that's where we were able to see the standard deviation. So I know you can back it up too. So I probably didn't have to do all that. And then in general, what does mu d represent? So mu d is going to be your null hypothesis. That's the average difference for all of the temperatures. So it's the mean value of the differences from the population of matched pairs. It's what we don't know that we're trying to estimate. So that's what that first one's going to feel like. When you go on to 2, 2 is going to feel a lot like these other ones. So what I would recommend is to delete these differences columns that we created. So if you click on the little arrow, you can clear these columns, the variable 1, the variable 2, and make it all clean like that. So let's read through this problem. So the following data lists the ages of a random selection of actresses when they won an award in the category of Best Actress, along with the ages of actors that won the category of Best Actor that same year. The ages are matched according to the year that the awards were presented. Use the sample data with a 0.01 significance level to test the claim that for the population of ages of Best Actresses and Best Actors, the difference have a mean less than 0. Okay, so we're making a claim that the mean is less than 0. So we're going to choose a less than, and we're going to choose 0. I think every time they'll choose 0, but it is left open. Null hypothesis is always equal to, and the number in the null hypothesis is 0. So we'll check that. So we just got that from properly reading the claim. Now we need to identify the test statistic. So what do I have to do? I have to enter in these years very carefully. So I'm going to go over here to StatCrunch, and I'm going to go across that first row and put them in this first column. So 29, 25, 28, 30, 33, 25, 25, 38, 29, 33. So that's not just a list of 10 things. They're paired up with these other guys. Using StatCrunch drastically reduces your workload, because what you would have had to do is hand compute the mean and standard deviation, put it into another formula, run that formula, get that value, and decide what to do. So this will be very nice. 62, 36, 38, 34, 31, 35, 51, 43, 39, 45. So notice it's not asking me what what D bar and S sub D are. It's just going straight to the test statistics that you actually use those two values, but you never need to see them. So if for some reason when you plug in the test statistic it doesn't turn out to be correct, take a look and see whether you plugged in all the numbers correctly. And take your time to do it carefully as you go, especially on the exam. And so that's what we have. So now we're going to go to statistics. We're doing t-statistics of paired data that's paired together. We're going to do column 1 and column 2. Notice it's selecting columns. We're going to leave these guys the way they are. And remember, mu d is equal to 0, and mu d we need to be less than 0. Perfect. So we're going to hit compute, and we'll have everything that this thing's asking for. It's asking for the t-score. Do you see where that is? It's huge. It's right here. We get negative 3.645. So I'll do 3.65. Fantastic. P-value. P-value is 0.0027. They want me to round it out to 3 decimal places. So that's 0.00 and 27. That 7 will make that to a 3. And we'll check that answer. Fantastic. Well done. Now, everything's the same. Is the p-value less than your stated level of significance? So the stated level of significance is 0.01. Is 0.003 less than 0.01? Yes. Since the p-value is less than or equal to the significance level, so it's interesting that they put or equal to, we're going to reject. Anytime that's the case, anytime you're less than the significance level, we're going to reject. So there is sufficient evidence to support the claim. And we'll check that answer. And they'll say, great. Now there's 2 parts remaining. A confidence interval. Well, how are we going to do the confidence interval? Easy. Now remember, this was a one-tailed test. So since it's a one-tailed test and confidence intervals are two-tailed, I need to adjust that 0.01 to be 0.02. So when I go here, I'm going to click Edit and say this time I want a confidence interval. And it's not a 95 and it's not a 99. It's a 98. Again, 0.01 is the stated level of significance for a one-tailed test, so it would be 0.02 for two-tailed. If I took that same one, sorry, my trackpad's not working really well. And so They want it, the one that's appropriate would be a 98% confidence. And so we'll hit compute, and we get two values. Negative 21 point, they want me to round to one decimal place. So 21.1 to negative 2.7. And we'll check that. And it tells us we did great, right? Of course we did. We used StatCrunch. So let me tell you what that means. It means on average, the difference between the actress and the actor could be anywhere from negative 21.1 years to negative 2.7. And since we're doing actress minus actor, the top minus the bottom, it means that the actors are older by, on average, at least 2.7 years, but maybe as much as 21.1 years. So since the interval, remember the number that we care about? We care about 0. Since the interval contains only negative numbers, we reject the null hypothesis, because the only way that we will fail to reject is if 0 is in that interval. If it contains 0, then we would fail to reject the null hypothesis, because it could be that the average difference could be 0, which would mean that our null hypothesis couldn't be rejected. And so we're going to check that answer. Next question. And what you're going to find is we're doing the same thing over and over, right? So what if I jumped, maybe there's a faster way to jump, I know there is. Let's jump all the way to 8. You saw some big numbers with that last one. Just be patient. So let's take a look at this last one. A study was conducted to measure the effectiveness of hypnotism in reducing pain. The measurements are centimeters on a pain scale before and after hypnosis. Assume that the paired sample data are simple random samples, and that the differences have a distribution that is approximately normal. What that allows us to use is the t-chart. Construct a 95% confidence interval for the mean of the before minus after. Perfect. So what are we going to do? We're going to recognize that we have a new problem, so we're going to get rid of this data. Whoops, I deleted the column and everything worked out okay. So you can either delete it or clear it. And then I'm going to be really careful. The first before score is 5.6. And so you could just pair them up. You could do 5.6, 6.4, and then come back. 3.5, 2.4, then come back. So there's different ways to put those in. 8.3 is paired with 7.4. 9.0 is paired with 8.4. 7.2 is paired with 8.3. 6.2 is paired with 6.8. 4.3 is paired with 3.8. And 2.8 is paired with 2.2. So I have 7 pairs of data on my StatCrunch. There's 1, 2, 3, 4, 5, 6, 7, 8 pairs of data. Oh, I do have 8. Sorry, I don't know why I thought I had 7. So that's good. So you could do a quick look across the top, make sure that those numbers are all okay. Across the bottom of the after scores. And then if that's all okay, StatCrunch is going to help us out. We're dealing with t-statistics for paired. For paired. We're going to have variable 1 be the before, variable 2 be the after. We're going to do the confidence interval, and they want a 95%. So all we have to do, since 95% was a default, is hit compute. It tells us some things. Tells us the degree of freedom 7. The mean of the differences was 0.15. So we can see on average the before score was higher, but just barely, right? So let's look at what we have here. We have a negative, and how do they want us to round? Make sure you look at that. 0.56, because they want it out to 2 decimal places. It was 557, so that's 56. To positive 0.857, so 86. It's saying great. So look what that means. It means that the differences could be negative, which would mean that the after score was higher, that hypnosis actually caused more pain. Or it could be positive, which would mean that the pain was reduced by that. Or it could be zero, which means there's no difference in pain. Does hypnotism appear to be effective? No, because the confidence interval includes zero is the right answer. It is definitely not effective. It would only be effective if we didn't include zero. Right? It actually would only be effective if the differences were positive the way that we're subtracting them. We would want a lower after score. We would want our pain level lower after we do the treatment, which would mean that we would have a situation like the second one there, that I had a pain of 3.5 before hypnotism and only 2.4 after. That's effective. But we're finding that for the sample of 10, their average is effective because it's 0.15. However, we're basing this only off of 10 people. We got to go look at more, because right now our confidence interval includes zero, which means it's not effective. And we're done. That's the way the 9-3 section will go. So give it a shot. StatCrunch is there to help you. Hopefully looking at the videos and going over them again can provide some clarity to the process. But let me know as you come to future Zoom meetings. Or just via email, right? I can answer your questions via email.